Hello guys, and today I want to use this video to explain these worksheets that I gave you yesterday. Okay, so can you please take this out? Once again, if you haven't tried this worksheet, would you please stop watching this video first? Okay, so now A, using the data booklet, calculate the relative molecular mass of PCl3. So you can check out your periodic table. So it's easy, right? PCl5, the P is 31, so plus. So you have this number, and then likewise, you work out the molecular mass of each one of them. Okay, so that will be the answer of this part. Any question? Oh, then B啦, B. 15 grams of phosphorus pentachloride were placed in a sealed evacuated vessel of capacity, this volume, okay? Well, you can see basically the volume, temperature, or SI unit already, and the pressure as well. So it's very easy. You just plug in the number, then you can find what you need to find. So PV equals to nRT. I hope you will not forget this equation. Normally, when the pressure, volume, temperature are given, you have to use this equation, okay? So the pressure is this, 3.1 times 10 to the power of 5. Volume is given this one already SI unit, okay? So number of mole is equal to mass over molar mass, right? So the mass is given 15, and the molar mass is the question is asking you, right? So, and then the gas constant is 8.31. You can find this data from your data booklet, and the temperature is also in K already. So, okay, then you put everything on one side and MR on the other side. Let's work out. So it's 190.19, okay? 190.19 is the average molecular mass of the gaseous mixture. Are you okay with this? Very easy, right? C from your answers in A and B, using the two formula given below, this one and this one, calculate a value for X. So basically, this is you plug in the number by into the given equation, then you can find what you need to find. First, hence show that the KC has a numerical value. This kind of question is very good because after calculation, you can check if your answer is correct. So basically the X will be equal to the MRPCl5, okay, here, which is here, PCl5, can you see that? So you plug in this number and the average is this number, the answer you work out in B, okay? So it's 208.5 minus this number, 190.19 over 190.19. Oh, then we work out this number first. It's 0.09627. Okay, I will write down more decimal places so that my answer will be more accurate. Normally, it's 4 significant number in the middle of the calculation and 3 significant in the last answer, okay? So now once you got this number, you're going to plug in the X into this. The KC will be equal to x squared, right? So will be this one over 1 minus x. So it's 1.0. Yeah, so it's the same. Can you see that? Okay, D 啦 predict and explain how the position of equilibrium may change by separately increasing the pressure. And well, this is easy lah. This is basically Le Chatelier, right? Le Chatelier's principle. Increase the pressure. Okay, let's just take a look on this. Gases, gases, gases. Altogether, one gas molecule, two gas molecules. So by increasing the pressure, the system doesn't like it. It wants to oppose the change by shifting to a side with fewer gas molecules. Since the left-hand side has fewer gas molecules, only one molecule there, so the equilibrium position is going to shift to the left, right? So you can write it down, increase the pressure, equilibrium position shifts to left, right? Since increase in pressure will favor the side with fewer gas molecules. Okay, and right now your LHS, right left hand side, has fewer gas molecules. Okay, oh. Now then increasing the temperature, then you have to look at this one. As I told you so many times, this given one refers to exothermic, refers to a forward reaction. So the forward reaction is endo, right? If you increase the temperature, the system doesn't like it. It wants to oppose the change by absorbing part of the heat, okay? So by doing this, it has to shift to the endothermic side. From this example, the equilibrium position has to shift to the right, right? Because the forward reaction is endothermic. So favors endothermic reaction, which is the forward reaction. And you have to mention the forward reaction is endothermic, and since an increase in temperature favors endothermic side, so that's why it is shifting to the forward. Any questions so far for this one? Hope then I try to explain this one as well. I hope I can have enough time. Then I will leave question 3 to the next video, maybe combined with the worksheet I just gave you. Okay, solid A, solid, gas, which means that at equilibrium calculation, this one is not included, okay, because it can't contribute to the pressure. When heated, it decomposes into B and C. Writing expression for the equilibrium constant Kp, Kp, instead of using concentration, we use partial pressure, okay? So, okay, so the A will be equal to Kp, and then since only this one and this one, we just consider these two. So it will be partial pressure of B times partial pressure of C, okay, at equilibrium. The two comes from the coefficient, okay? Why A is not included? You can say A is a solid, okay, that doesn't contribute to the total pressure. Okay, it cannot exert any partial pressure on the total pressure. Okay, temperature T, okay, given, of course, calculate and then calculate, okay, as expected, all right? So, now, your equation is like that. Since the A gradually decomposes to B and C, right? So, its mole ratio, small ratio is always 1 to 2, right? It's always 1 to 2. Wherever there is 1 B produced, there is always 2 C produced. So it's very easy to work out their mole fraction. You need the mole fraction. So the mole fraction of B will be the total number of mole over its mole number. So it will be this one. Since you only have two gases, if one is 1/3, the other one should be 2/3. Okay? Because when you sum up, it has to be equal to 100. Then it's easy lah. So you work out the partial pressure of B. It will be the mole fraction of B times the total pressure as what we have learned. So the mole fraction of B is 1/3. The total pressure is given. So it will be this one. Okay? Likewise, you work out the partial pressure of A by times the mole fraction of A times P total. So the mole fraction of A will be 2/3 times the total. So it will be 2 times this one. Okay, now once you work out this one, it's already almost done because you have this partial pressure, right? And you have this partial pressure. You just plug in this into this equation. Okay, then we can do this together. So Kp will be equal to Pb, this one. I don't have enough space, so I will write on the words. Together with this one. This should be C, sorry, C. Okay, C, okay? So C, okay? Together with this one, C, that is the 2 times 10 to the power 3 square. Then you use the calculator. So it will be equals to 4 times 10 to the power of 9 PA. PA cube, okay, because you have 1 and 2. Okay, so that is the end of this question. You have to give the unit, remember, give the unit. So it's PA cube because you have 1 PA, 2 PA, when they times together, PA cube. Okay, any question? The idea is you have to work out the partial pressure of each of them and then plug them into the Kp equation, but do not include A because A is solid. Do not include A because A is solid, okay? So I get back to you to explain the last question, which may be the hardest one for you, but actually it's easy. Anyway, I will get back to you. Any question? Remember, if you haven't done so, please try to attempt the questions first before you watch this video. Thank you.